Good morning, ladies and gentlemen. Good afternoon, whatever the case may be. Today we're going to talk about Unit 6, Lesson 2, Logarithmic Functions, Activity Number 2. This is a very easy activity. This should be a fairly short video. So we know what the logarithm, we know what the definition of logarithm is. So the definition, I'm just going to put it up there. Log base a of x is equal to y if and only if the logarithm is the exponent. Here's your base. A to the y is equal to x. And that's the definition of a logarithm. We know that, and we've worked well with that in the past couple days. Today we're going to look at two logarithms that the calculator, that our graphing calculator, in fact, any scientific calculator will be able to evaluate. And the first one is going to be the log base 10 of x. This is called our common logarithm. And if you go to the graphing calculator, you will see a button that says just log. And it doesn't really have a base, but the base of that log in your calculator is just is just 10. So here I have here the base here that you don't see is 10. And what is log base 10 of 10? Well, that's going to be 1. And why is that going to be 1? Because 10 to the 1 is equal to 10. And here again, I see this log base 10 that you don't see the 10. The 10 is hidden. Log base 10 of 100, what's that going to be? That's going to be 2. Why? Because 2 squared is equal to 100. And I'm going to switch over to the graphing calculator and let you see where this log base 10 is. And if I come here to my home screen there, that log is going to be down here. And you see that guy right there. Whoops. Let's clear that out. If I push that button and I put 1,000 in, and we know what that's going to be. Log base 10 of 1,000 is going to be 3. Why? Because 10 cubed is 1,000. And we can take the logarithm of the log base 10 of anything. In fact, we can go log base 10 of 15, which is going to be a decimal number, an irrational number. So there you go. Log base 10 of 15 is 1.17609. So that's one of the logarithms that the calculator can do for us, is log base 10. So the other logarithm that the calculator can do for us is associated with the number e. And we've talked a week or so ago about the exponential function e to the x. And just to recall briefly, the number e is a number that is similar to pi, and that is a irrational number ending non-repeating decimal. And we're going to wait till calculus to formally define e, but it's going to be suffice for us to know that it is a number between 2 and 3. So if we find e to 4 decimal places, we can jump back here to our calculator, and we can just, e is always going to be that number above the, right there. So to 4 decimal places, e is 2.7182. So e is going to be 2.7182. So we just know that e is going to be there between 2 and 3, closer to 3. And we know what the exponential function looks like right there. So if it is exponential, it has an inverse. And we've gone through the steps to finding inverse. Here we go right here. We have y is equal to e to the x. And by definition then, this is the base. So we're going to have a logarithm with a base of e, and the logarithm is equal to the exponent. So right here I have e to the x is y, e to the x is y. That says that I can take this expression and write it as a logarithm like that, and that's how I would actually solve this expression for x, because I'm finding the inverse. Now I'm going to swap the x into y. Log base e of x is equal to y. And that is indeed the inverse of the exponential function e to the x, is this log base e of x. This is so important. Well, e to the x is defined as the exponential function, the most important exponential function of all. And in fact, the inverse of this exponential function, which is log base e of x, is so important they give it a special notation, and that special notation is just ln of x. So when you see this, That is log base e of x. And that's called the natural logarithm. There's a lot of natural phenomenon that follows the relationship between e to the x and ln of x. That's why we're going to name that the natural logarithm, and it's just simply ln of x. So important we give it its own special notation. So we're going to go to our graphing calculator, and if I want to go ln of 0.5, that's going to be this negative number. Ln of 1 is going to be 0. Well, that's easy. Why is this true? This is true since e to the 0 is equal to 1. And with our graphing calculator, you can do this yourself, and I'll show you where that key is. Ln of 0.6931. If I go to my graphing calculator, and here is the ln button. It's right below the log base 10 of button. And if I go in log of 2, ln of 2, natural log of 2, and there's where I got that 0.6931. Hey, what is ln of e? Oh, that's that, and that makes sense. So ln of e, and we're going to write this one down here. Ln of e does equal 1. Why? Because the base here is e. E to the 1 is equal to e. So this is going to be a very important statement. Ln of e is equal to 1. We're going to be using that a lot. So the other interesting, well, it's not interesting, that it's just a true fact, is that these guys are inverses. And if they are inverses each other, we know that this is the formal definition, the analytical definition of two inverse functions. F inverse of f is equal to x, and f of f inverse is equal to x. And that's what's going on here. So I have e to the ln of x is equal to x, and I have ln of e to the x is x. This is an easy part of the statement to realize, because what this statement is actually asking, I have log base e of e to the x is x. Why? Because e to the x is equal to e to the x, and this is your base here. So base exponent is equal to e to the x. So that's an easy one. This particular statement is a little bit more elusive, if you will, but that just flows from the analytical definition of inverse functions. If that's the case, and this is going to be hard for a lot of people to see, e ln of 5, let's see, that's just 5. Why is it 5? Because of the fact that e to the x and ln of x are inverses of each other. In like manner, ln of e to the 27 is simply 27. This is easier to see by definition because this says base of e to the 27 is equal to e to the 27. So that's a quick little video over this particular activity, which is going to be very important. You will need to know these two logarithms, log base. You are going to need to know this. When you see that, that means log base 10. And when you see this, that means log base e of x. Short little video, Unit 6, Lesson 2, Activity 2, over calculators, using the calculators to evaluate two special logarithms. All righty.